Okay, thank you for all those new people who are joining right now. Thanks again. We are going to start the webinar. We are going to start Let New Ideas Bloom with Coding Robots webinar in partnership with Robotical and also Kai's Clan. We have here Hal from Robotical and also Bruce and Ronelle. Thank you so much, guys, for joining us in this amazing webinar. We also have Amy George, which is our account manager, and she will just guide you through all these amazing new ideas that you can get for your classroom. So let's just go ahead and hear from it. Amy.
Thank you, Maria. Thanks everyone for joining. I'm just going to run through the agenda really quick. I'm going to tell a little bit about Robot Lab, introduce myself, Robot Lab in a nutshell, and areas of expertise. Then we're going to go to Kai's Education introduction with their KaiBot demo, and then transition to Robotical introduction and Marty 2 demo with some Q&A afterwards. So we have a special offer. They'll be giving away one KaiBot to any very intelligent questions, teacher-related questions. So please be engaged in the chat as we go through the webinar, and afterwards we'll go through the Q&A. Also through Robotical, there is a 2-week trial for Marty within the US. So also look out for those slides as well and information. So my name is Amy. I am an account manager for the K-12 market in the US and around the world. I've been with Robot Lab for over 2 years and just help implementing AI labs, virtual reality, and we have the replacement for Google Expeditions, VR Expeditions 2.0. We launched that a few years ago. About Robot Lab, we were founded in 2011. Our headquarters are in San Francisco, and we are serving over 32,000 customers worldwide. We're present not only in the academic industry, but hospitality, banking, retail, healthcare, corporate, government, and public administration. We do all of the repairs here, servicing support through our office in California. We have a lot of partners down the way and award-winning programs that we've won. Some of our accomplishments are we're the sole distributors of the Now and Pepper robots in the North America and South America region. We're the creators of VR Expeditions 2.0, a replacement for Google Expeditions VR platform. And we successfully installed AI and esports labs at multiple locations, not only K-12, but also universities around the world and in the US. I'm going to introduce Bruce and Ronelle from Kai's Education. Bruce has a passion for technology, which led Bruce to create Kai's Education, a more exciting way to teach coding. As a father himself, Bruce understands the importance of computer science in education and saw a way to make a positive impact through his collaborative coding platforms with Kai's Clan and the new screen-free AI KaiBot robot. Ronelle is the sales marketing education manager. She's a voracious learner, adventurer, entrepreneur, edupreneur, and a partner in learning with teachers and students around the world. Ronelle is an account executive currently working at Kai's Clan. Driven by her passion to inspire others, a love of learning, Ronelle's expertise is grounded in how we integrate digital technologies for developing global competencies and preparing students to succeed as the next generation of learners. So thank you so much. I'm going to pass it over to Kai's Education.
Hey, welcome to Wednesday. Yeah, we're coming to you from New Zealand. It is still dark at 7 a.m. But yeah, thank you. And I'm Bruce, and
And I'm Ronelle, and we create future trailblazers with Kai's Clan and KaiBot. So we're really interesting to get some good questions from you, and we'll be giving away a KaiBot. So yeah, definitely ask those questions.
Next slide, please. Okay, so in the classroom, learning coding is a challenge for not just teachers, but also for students. And we've developed something that's pretty unique in New Zealand that goes from screen-free using just coding cards and progresses through.
And although we say it's K-8 with curriculum aligned lessons, it's really important. We want teachers that's never ever coded to also learn how to code. So you can learn with your students using the screen-free coding cards.
And as you'll see, we support Braille, so we are fully inclusive for hard of hearing, hard of sight, as well as hard of learning, which I was one of those problem students, a bit of a ADHD, and always struggled to pay attention in the classroom. But that's, that gave me the skills I have today to be able to develop kids like myself to learn coding. Next slide, please. So for somebody who's never coded before, whether it's an adult or a student, how do we start? Well, the best fundamental that we've tried in classrooms is to have one student act as the programmer and then the other student to act as the robot. Then the programmer student lays out a sequence of cards to say move forward, turn right. You guys have all, you would have seen B-bots and the likes like that. And we start without a physical robot. So we just start layering down these sequences. We're creating a scaffolding system that we're going to grow on and we're going to build. And I'm going to show you that today.
And then you'll be able to walk around the table and get to the cat. That's awesome. Right. Next slide, please.
I love chasing the cat. That's why I did that.
So screen free. So we've got these cards that you basically lay out in your sequence and you tap it, beep, 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 and then you run your program. You can then go and actually add Kai tiles, and you can see up to 60 tiles. You can do lots of puzzles and mazes. And I think one of the biggest problems for teachers is the kids make mistakes, or they've got something wrong. And then it's these little hands, miss, please help. I don't know what to do. While KaiBot has also got a debug function, so the kids can problem solve themselves.
So KaiBot's like a little a teacher of coding, because it walks the kid through or the student through learning to code.
And then another problem are these robots that always go flat. Batteries, man, we had to make something different. So we got a mini Roomba. So you will see KaiBot actually drive itself back to the autonomous charging dock and charge itself. Next slide, please.
Please could you check if our video is pinned as well? Okay, so with KaiBot, like it's a scaffolding system, we're cramming a lot into your heads at the moment, but you just got to think about a step ladder approach, and we're taking one rung of that ladder at a time. So now the third level of our ladder is adding in these magnetic tiles that you saw in the previous slide. And then we pair the robot with a Chromebook or an iPad or Android, and then we get a virtual mirrored view of the physical KaiBot in the virtual. And that's how we then extend it and transfer the coding card language into Python or Blockly, and we start scaffolding their learning.
So that's probably the difference between us and any other robot, is that we've got the physical robots with the physical tiles. There's lots of those, but then we actually match that with a virtual world. So you'll be in your virtual maze or your virtual escape room, or if you're going to do, catch the cube or something like that, hide and seek. So that's the point of difference with all Kai's education robots. And then we've got lesson plans. We all love some lesson plans. Next slide, please.
And loads of activities. So if anyone's got any questions, please pop them in the chat. We'll try and get through to them.
Right, my favorite subject, lesson plans. Well, we've got the normal lesson plans, and they focus on maths and social emotional learning and literacy. So that's really good. But we've also got this fabulous book now. It's 330 pages. It's a downloadable PDF, and it's written by Rudy Neufeld from Canada. So a very, very well-known author, has just fallen in love with KaiBot, and he's come up with all these lesson and activities. So it's all about coding through mathematical thinking and game-based learning. Next, please.
Now,
What's this doing here?
so KaiBot is our second product. We've been around for 4 years. You can tell by my age. And our first product is Kai's Clan, and Kai's Clan is a collaborative coding, robotics. It's like a STEM toolbox. It does AR, VR. You can sit inside the robot, and not the physical robot, and the virtual robot. And you can drive around on Mars, and we've got an Amazon warehouse simulation. It's a huge system, which is easy to use and very versatile.
So it's basically you start with KaiBot for that probably K to 3, and then you can actually grow with KaiBot as well. But then you jump over to Kai's Clan, and we really focus on that IoT, learning about data and the AR and the VR. And then, hey, the kids want to do their own Minecraft stuff, so bring that into Kai's Clan. Next slide, please. Oh, more lesson plans. Right, teachers, we are trying to make this as easy as possible. The difference, Kai's Clan is cross-curricular. So we do computer science, we do biology. So if you want to do smart gardens, we have got history, social, emotional learning. And then the best thing for us is teachers love loading up their own projects and what students do. So you can share that with the community as well. Right, next. I think this PowerPoint is getting too long now. I hope you've now not have any more. Next.
Jason's asked what's the cost is, and I think the Robot Lab team will get back to you about that. But how many students do you suggest using with KaiBot? So, I mean, it depends. If it's a primary school, we say what, Renelle? It's about 10 robots for about
20 to 25 students.
Yeah.
So we'll talk about this classroom pack. So that's about 10 robots. You can add some robots, about 30 tiles, some advanced coding cards, the platform, lesson plans. That's all free, no subscription. But let's show you. Yeah, here's the demonstrate. I heard KaiBot woke up here. Right.
Okay.
The sun must be coming up.
Can we stop the sharing, please? Thank you. Okay, awesome. So here we go. So what we've got here, we're going to switch cameras here.
Oh, good morning, Peppa Pig. Let's move you to the side.
So what we've got here is our little KaiBot. And as you can see, KaiBot has got a screen on it.
KaiBot has got a cute little cover, my unicorn. And as he drives away, right, let's go.
Little puke emoji. So here you can see him going to charge. So when the battery's flat, he'll automatically charge just like a mini Roomba. So the camera's a bit out of focus there. There we go. Okay, so what's first, Renelle?
Right, we're going to start with some coding cards. Hopefully with time, we're doing really, really well. And I am going to do something so simple. I'm just going to do that so you can actually see. I'm just doing a 1, 2, 3. Oh, I think it's a bit wrong way around, but let's do this. So coding cards, a whole box full of them, over 100 in the advanced coding pack. Record program. So these are our cards, wax, so you can chew them a little bit, but you can also laminate them. So we always start with a program start. We then have our program end, of course, and you'll see we've got little brackets that shows the students they start and they end. And then like all other programs, we have a run program. So what do we want to do?
What's the problem? Where are you going to start?
I'm going to start on 1.
So put the robot there and let's see if you can code the robot.
I want this robot. So I'm going to go forward. It's a little bit backwards, hey? Turn right, forward. Very simple. I'm going to go forward. Now you've got a little asterisk, so I can always put a number there, but I'm just going to go forward once. And what are we turning? Turn left. turn left, backwards, turn right. We're going to turn right. Yep, I think I'm going to do this. Turn right, forward, and end my program. So all we do now, you basically take your robot, tap the card, it tells you what it's just done, forward, turn right.
So the kids are programming the robot by tapping on the cards. Get a little countdown. So forward, right, and forward.
Phew, I did it. Right. So very simple that you can then actually grow and add, make it bigger. But hey, we love a challenge. Okay, so what I'm going to do is I'm going to build another shape, and you'll see this is going to become more specific when we do the next step. So I'm going to go 1, 2, 3. So it's just snap together tiles. You'll see very, very easy.
So these, yes, just snap together tiles. And these are magnetic tiles, so much like you probably have in your libraries or things like that. Renelle needs to go back to school to count. So each tile is numbered. I think you're upside down, actually. You better check the iTablet for that. So each tile is numbered, so we can use these in mathematics, and we can do variables, and we can do if statements, and we can really progress the learning. So here we've got a tablet version, and this we can pair with KaiBot as well. So you can do it screen free, or we can pair. You can choose a little character. You're upside down. So we've chosen our character. Now let's pair our robot. So on the robot, we have the ID. So you can see here, 836A. Select that. And then the robot is paired.
So now there's some tutorials that you can do. There's some coding guides, which is, how to move forward, turn left, all those kind of things, and load a project and scan. So we're going to load a project. We're just going to go, there's more lesson plans there. We're going to do training level.
So we have over how many KaiBot lessons?
55 on the dashboard, and then we've got 300 pages of them. Okay, did I do this right? Oh, upside down.
You're upside down. I thought you were upside down. So what's basically happened here is we've loaded a level, and the level has told us what's the layout to create. So much like if you are building a house, you need an architectural design, you've got a floor plan. So we're matching the floor plan with the house we're building as such.
My house obviously got blown down by the little piggies because it didn't work the first time. Right. Okay, it's so simple to do it. Just
so the 10 is in the middle. Okay. So now we check, we make sure it's matched, click OK.
We've got these fancy dancy mag tiles. Hey, let's make some, I think I can.
Corner. Yeah. So those are just your standard magnetic tiles, and we can use those to build mazes and stuff like that.
And especially when you start having those walls for mazes, that's really good. I'm just going to do something very simple. Okay, so I've done the same layout. Now what I need to do is add the charging dock.
You're done here.
Yeah, we've done that. So done. And done my tiles. So it's very intuitive, like what you need to do. Oh, so what do we need to do? Use KaiBot to tap the cards. And the aim is to actually come around here and pop the balloon. So there's actually a cube here with a balloon in the virtual world. Now you can go and add those physical things as well if you want to, but we just kind of focus.
So we need a code KaiBot to go around and get to the finished tile, which is tile number 9, which is there. So we're going to go around there, come
Okay.
back and hit tile number.
Right,
So
I'll
can
move
you
that.
code KaiBot to do that?
Okay, so we do a start. Gonna go forward. Ah, I can see this is a bit of a loop, right? Let's do a loop. Gonna go 1, 2, 3. 3 times loop. 3 times a loop. Yep, got that. And what does that loop look like? It's gonna go forward. 1, 2. Yep, forward 2. Right, and then we're going to turn left. Okay, turn left, and it's going to go forward 2, turn left, forward 2, turn left. That's the end loop. Am I
Yeah.
doing all right there, Bruce? And then I'm going to turn right.
You need to turn right. Yeah. So what we've got here is we've got a drive forward. We've got a loop 3 times, and you can see the green asterisk allows us to use a number after this card, because these cards are based on Python, and we've broken these down to go back to back to basics. So we're going to move forward 2 times, turn left, and we're going to end that loop. But that loop is going to run 3 times. Then it's going to come down here. We're going to turn right, move forward, and then we're going to end the program.
Okay. Whew, right, pressure. Okay, so I'm going to start. I'm going to go forward, loop start. I'm not focusing. Oh, I got a bug alert, missing number card. So after a loop, you have to say how many times you're going to loop it. So, okay.
I stole the number card from
All
you.
right, I can do this. So you start again. Forward, loop, 3 times. Forward, twice. Turn left. In my loop, going to turn right, go forward.
Stop there.
In my program.
Okay, so before we run that, we just want to show you something, is that, whoops, sorry about my camera work. I didn't go to camera school. So you click on that, that code, those coding cards have been converted into Python text-based coding. So we're starting to teach the principles of laying out cards in the correct manner to learning how to code.
Okay, it tells me. So I'm going to run my program and put it on row tile 1.
So now what you're going to see is both the physical and the virtual are mirrored together.
Oh, I'm going to hit the Dogecoin. Yes, 1, I've got it. Right, keep going, little robot. Come on, Mr. Penguin. You can see there's some lasers that you can add, and there's gates, and there's oil slicks. So there's it's a game builder as well, which is really cool. You can do this. Come on, Mr. Unicorn. Ah, another Dogecoin. Oh, there's that block. Push, 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 push. Yes, I got balloon. Ooh, turn back and back.
Turn right.
Turn right. Go, 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 go. Yay!
Oh, you got to the finish line now. Well done. I'm going to award you with a certificate.
Right, now I got 7 Dogecoins. I used the loop, so I got 70 points. Wow, that's pretty good.
So here we do an assessment of the child's, of Ronel's coding ability. And here you can see he's got a little bit of movement, collected some Dogecoins, and now you can collect your certificate. So
I know there's something waiting. Ah, I got my loop badge. Yeah.
so she gets some little stickers and she can save that. This is available on the Chromebook, iPad and Android devices.
Okay, so to recap, you basically have your screen-free coding cards. You tap them, you lay them out. If you make a mistake, you can obviously go and fix it. There is repeats. There is social emotional learning. So if you're happy, if you're lonely, if you're surprised, you can actually tap and the robot will do a little dance for you. We've got loops. Maths, oh, greater than, equal to, lesser than. We've got them all. Variables. So when we start teaching variables, we've got those cards. So a lot of students don't just want to do. Can you not show my coffee cup at the back there? Thank
sorry.
you. I know I needed coffee. But you know, there is all these coding cards that you can then use, which you then progress and have your companion app. So our Conundrum Lite is our companion app.
Right. We've got a bunch of questions.
Ah, good
Yes, you have a lot
So-
of questions. I don't know, guys, if you want to answer them maybe at the end, and then Ronel, you will select somebody who can win that KaiBot, and then we can continue with Hal. If
Okay,
you want,
we'll
yeah,
do
so
that.
we can just, so thank you so much, guys, for your question. We'll address them at the end. So stay tuned. There's a winner for KaiBot, so just stay there, and then we'll continue with Hal. So thank you, guys. That was an amazing demonstration from this amazing tool.
Thank you.
So we got a.
No, we're going to do the questions afterwards.
Oh, okay.
Yes, and then Amy, do you want to introduce Hal? And then, yeah.
Yeah, thank you, Ronell and Bruce. This is awesome. We're always a fan of Kai's education. Now we have from our robotical team, Hal Speed. He's the head of North America for robotical. Hal Speed is currently the head of North America for robotical and is an advisor to nonprofits, including KidSpark Education, AI for K through 12, and Tiny ML for K-12. He was previously the chief of global engagement for the Microbit Educational Foundation. Hal is also the founder of CS4TX and a member of the K-12 Computer Science Framework Writing Team. Thank you so much, Hal, for joining us.
Thank you, Amy. Sorry to make you read all that. Basically, I care a lot about this. You know, in the digital age and increasingly the epoch of intelligent machines, coding, computer science, computational thinking have become a foundational skill that all students need to learn. And so we're going to talk a little bit today about Marty the Robot to help introduce young learners to these concepts in a fun and easy kind of way. So we go to the next slide. Before we get started, I just want to let everyone know the best way really to learn about Marty is to get hands-on and bring Marty into the classroom and use with your students. So Robot Lab provides a free 2-week trial. You can go to this URL, and I think Maria will share that. We'll also post it again at the end. But the best way, if there's any remote interest in Marty, is to sign up for the free trial, and we'll provide some additional training and professional development, and you can use it in your own classroom with your own students. So let's go ahead to the next slide and introduce Marty, the real walking, dancing, soccer playing robot that also can talk and bring learning to life. So Marty is a humanoid robot, which as Robot Lab talked about, they have some other humanoid robots at much more expensive price points. But this is a way to bring that humanoid form factor into K-8 and even potentially K-12 at an economical price and still have that same kind of social emotional engagement and fun learning that we know humanoid robots are so fit for. All of the arms and legs articulate, so Marty can walk, the legs bend and have a natural walking motion. The arms move, the eyes move. There's numerous built-in sensors, and we'll talk a little bit about some of those in the demo. There's an onboard color sensor. There's infrared sensors to detect obstacles and to detect the ground. There's a motion sensor built into Marty's head to detect acceleration, in addition to the speaker to produce sound. So let's go ahead to the next slide and we'll look at some of the different software methods that we can use to program Marty. I should also note that Marty does come pre-assembled. That's a question we get asked quite frequently. So yes, it's ready to go right out of the box, pre-assembled. Each Marty comes in its own carrying case, and we'll take a look at that in a couple of slides. So we also believe in starting off young learners with unplugged or screen-free activities, and we'll demo that using some color tiles, a simple approach to use 5 different colors to discuss and teach directions and sequencing with forwards, backwards, left, right, and then stop and celebrate. From there, we move into our software which works on tablets for iPad and Android, as well as a web version that can be used on Chromebooks, Windows, and Mac. And then for more advanced learners in middle school and even potentially into high school, Marty can also be programmed using Python. And in that case, we have a library, a Marty Pi library, that gets pip installed into your local Python development environment. Let's go ahead to the next slide and to give an idea of just how we progress from the pre-K 4 and 5-year-olds, starting off with Unplugged and then into the remote control sequencer. We have junior blocks that have icons and images for pre-readers, very similar to Scratch Junior, and then more traditional block-based programming with text and words. That also exposes a lot more of the functions for the sensors, as well as some of the text-to-speech and sound capabilities. And then, like I mentioned, Python. The next slide has an illustration of our scaffolded lessons. We also have over 100 free lessons online. You can go to robotical.io and go to the learning portal and look at those based on the Computing and the Computer Science Teachers Association standards, but then also many cross-curricular lessons. If we look at the next slide, that include mathematics and science that are aligned with NGSS. We also have some state level alignments with the Texas TEKS and then the Georgia GSEs, in addition to other cross-curricular lessons in English language arts, SEL. You can go through and pick your different grade levels, different coding environments, and filter on the concepts in our learning portal that you want to teach. Let's go ahead and go to the next slide. We talked about the benefits of humanoid robots. We've assembled some research around that and put it together into a white paper. So feel free to go to that link. I think Robot Lab is also going to make these slides available after the webinar. And so you'll have this and be able to click on the link to go directly to that. I just want to highlight some of the advantages on the engagement side, but also for students with special needs, especially on the autism spectrum. The research shows a better connection with a humanoid, a humanoid form factor for robots. And you can read that white paper as well as go to some of the academic research on this topic. The next slide will look at the offering that Robot Lab has. So we sell classroom packs of 5. So depending on your classroom size, 5, 10, or 15 robots, we suggest kind of in the same neighborhood of 2 or 3 students per robot. Each of those 5 packs is going to come with 5 robots, and that includes all the sensors that I mentioned. The robots also come with their own sticker sheets so the students can decorate them. You see a couple of different examples here on my video feed. Each robot has its own carrying case with a handle. So if this is in a lending library or maybe a cart that's going from classroom to classroom, it's easy to store so that the robots don't get damaged. One of the very unique things about Marty is it has a removable battery. And so in the class pack, there are 2 batteries per robot, so extra batteries, and an external charging cradle that allows you to charge the batteries and still use Marty in classroom instruction time and not have to worry about kind of that battery management and charging management. The batteries run for over 3 hours and typically take about 2 hours to charge in the cradle. So the idea is that you always have a fresh battery ready to go and don't have to worry about it. Marty can also be charged over a USB cable, but we really recommend the classroom packs to get the charging cradle and the extra batteries. And then we have 2 different types of unplugged color cards. We have the paper cards that come with each of the robots. And then in the classroom set, we have a set of premium tiles, similar to a mouse pad, that have a neoprene and a cloth kind of cover that will have more durability in the classroom. And then all of the products from Robotical come with a 1-year warranty through Robot Lab. And then they also provide some additional support and curriculum integration if you're interested in things like that. So why don't we go ahead and move into the demo. So let me see if I can, so you can, yeah, there you go. We'll set up, I'm using the premium tiles. I'm just gonna have a green and a red adjacent to each other. Can't quite see that, can you? And then I've got my Marty. I've already put the battery in the back of Marty's head. It's really easy just to pop in. No tools required. I think, no, Marty needs to be put into unplugged mode. And so we should hear Marty say unplugged. Yep. And so what that does is now we notice that there's a white LED on Marty's left foot that is looking for the color values. And in this case, I'm using a green tile and a red tile. Green is going to tell Marty to go forward. Red is going to tell Marty to stop and celebrate. But there's additional colors too with the cardinal directions. We've got purple, yellow, and blue for left, right, and backwards. And so the students can develop a maze and do some sequencing, obviously some problem solving as well. So let's set Marty, let's set Marty down on the green. That was a little quicker than I expected. Let's do that again. Come on, Marty. So we set Marty on the green. Marty's going to take a few steps forward and then is going to get to the red and then stop and celebrate. So you can see we're getting those quick wins right out of the box with Marty. We're building the confidence with the students, but then also with educators, because as we know, this is a subject that some educators are a little bit concerned with and may not have a comfort level. And so how can we build that energy and excitement in the classroom and get coding with Marty? And the color tiles are a quick and easy way to do that. So now I'm going to take Marty out of unplugged mode. And so when I set Marty on the color tiles, it doesn't do anything because we've essentially turned off the color sensor and it's no longer looking for the color of the tiles. And we'll move into the software now. I'm going to share my screen. I'm in a web browser, but this will look the same as if you're in a tablet device. Where am I gonna? There we go. Too many robots for the screen. So you can see, first thing we need to do is connect to Marty over Bluetooth. So I'm gonna click to connect. I've given my Marty a name, in this case, Martina. I've also used one of the stickers to say, hello, my name is Martina. But we know students can also mispair with the device. So we have a kind of a two-factor authentication built in. So I'm going to select Martina. But in the classroom, this list may include multiple robots if you've got 10 or 15 different robots. It's going to come back with a color sequence. In this case, it generated a unique sequence of yellow, red, blue. And I don't know if you can see it on my screen, but Marty, on the back of Marty is the same color sequence of yellow, red, blue. So indeed, this is the robot that is at my desk that I want to go ahead and pair with. So I'm going to say yes to confirm. And so now we'll get a successful pairing in the app. The name of my robot, Martina, shows up. And then on the back of Marty, the a blue LED that says that we're connected over Bluetooth. So from the unplugged lessons with the color tiles, we're going to move into the controller sequencer. This is another easy way to get started. Most robots have some form of remote control. And so when I press a command like step forward, Marty steps forward. If I say wave your arm, Marty waves the arm. So it's like a remote control car. The robot's going to do what I tell it to do. But we introduced another step before we got to drag and drop programming that we call a sequencer. So if I toggle this switch here, you'll notice that the racetrack kind of comes alive into the foreground. And so now when I press a command, the robot is going to respond directly to that, but that command is going to get populated into the racetrack. So if I click move forward or wave or wiggle the eyes, each of those commands is getting populated into the racetrack. It's not drag and drop yet, because these young learners may not have quite the dexterity to do the drag and drop. It's just selecting step 1, step 2, step 3 to start to build that sequence of commands. And then when they're ready to run the program, click the green flag, and then the robot will then execute the commands. And as it's going through the racetrack, each one of those commands get highlighted so that the student knows which one that was. If they make a mistake, they can simply click the red X to eliminate a command, or to start a new program, can hit the clear at the finish line. The next on our learning journey is into Marty Blocks Junior. So as I mentioned before, this is very similar to Scratch Junior. The main difference here is instead of Scratch Junior having a front of the stage view for the sprites, we have a bird's eye view looking down on the top of Marty's head. So as Marty moves in the real world, the sprite on the screen is also going to move in the virtual world. But the menus are very similar. The blue menu is going to be for movement commands, including dancing and the soccer ball kick. The magenta menu now introduces some more emotions and facial expressions, some eye movements, some colored eyes as well. You'll notice that we have built-in repeat capabilities. So something like the arm wave has a number underneath it. We can click that number and then a little number pad comes up and we can select how many times we want to repeat that particular block. On the eye color block, we actually can then select what color we want the eyes to be. So maybe we'll pick red, and I can add that into my program there. The green menu is going to be for sounds. So at this level, there's 6 built-in sounds and then a little bit of control logic and end. So we can go ahead and click the green flag either down here in our coding canvas or up here at the top. And you'll see each of these steps also gets highlighted as Marty executes. There's the wiggle and some sound, and the eyes turn on, and a little bit of a wave. And then lastly, let's take a look at Marty Blocks. This is also very similar to Scratch. So if your students are already programming in Scratch, this will be very easy for them to migrate to. The menu structure is the same. The main difference here is all of the Marty specific blocks are going to be in this dark green. So if we want Marty to move, or want Marty's eyes to light up, or want Marty to make sounds, all of those are going to be in the green blocks with Marty's face. Let me set, this is a simple program to illustrate some cross-curricular learning. In this case, we're using the 12 LEDs in Marty's eye to use that as a clock face. And so we'll have an LED for the hour hand, one for the minute hand, and then one for the second hand rotating around the eyes. And so I'll click the green flag. This also introduces the concept of variables. It's getting the time from my local computer. So when I click the green flag, don't know if you can quite see that on the video. So the blue LED is going to be the hour, the red is the minute hand, and then the blinking green LED are the seconds as it moves around the clock face there for Marty. But all of the sound functionalities, the sound library, we have access to all of the instrument sounds and animal sounds. Students can also record their own voice and then have that voice play back through Marty. That'll be under the sound menu. So as you add sounds to your library, those will get added here into the drop down. And then we have built-in extensions also to do text-to-speech, and as well as some language translation. And so there's the ability to teach other languages and have Marty help in that endeavor. And then lastly, just wanted to highlight some of the sensor data. If you're familiar with Scratch, you know the block shapes mean either it's a number if it's got the rounded corners, or if it's got the pointy ends, that's a Boolean expression. So that's going to return a true false or yes, no. And so we have a mix of both. For the infrared sensors, that's going to be a Boolean, and for things like the color sensor and the motion sensor, those are going to be numeric arguments. So I think that's all I had planned to show today. So I can stop sharing and then just give a quick reminder. Again, if any of this seemed interesting, just go to the link on the Robot Lab website. For those educators in the United States, we'll provide a free 2-week trial, and you can get hands-on and learn about Marty yourself. Thank you.
Thank you so much, Hal, and Ronell, and Bruce. I'm very excited for all of these opportunities for students to be able to learn how to do the different coding aspects. Here's that link again one more time, but it'll also be in the chat for you. We're going to take it to Q&A now. Maria is going to be facilitating that, and we are available for any questions. Maria, go ahead.
Yes, Amy, can you stop sharing your screen so we can see each other? Thank you. So I know Ronell and Bruce, you already answered a lot of questions about KaiBot, so that's awesome. Hal, you have some questions that I'm going to go ahead and ask for you. So Tracy is asking, is Marty better for individual learning or for teams? If it's for teams, what will be the maximum number of students per team?
Yeah, so the 2 or 3 students per robot is what we suggest. There are ways to have pair programming, so one person can focus on the software, one person can focus on executing with the robot. You can also trade robots, so they can do their software independent of the hardware, and then pair with the robot to then run their programs on the hardware.
Awesome. And then Sandra is asking, do you provide teacher professional development for the implementation of Marty?
Yes, we will provide some training, and I think that might be an area also that Robot Lab would be able to assist with.
Juan Rodriguez is asking, great kit, how do our administrators can make contact to purchase?
I think that's a question for Robot Lab.
Yeah, I think Amy, you can yeah, write at amy@robotlab.com. She's our account manager. If you have questions related to either KaiBot or Marty, we'll be more than happy to help you with that. Yeah. And then
and the store. I mean, Robot Lab has a store, so you can request a quote directly off the Robot Lab website.
And then Amy, I think this is for us. Parker is asking, I saw that you partnered with University of Texas Austin. Is this program applicable at the community college through university level, or do you just recommend these for K-12?
No, I would say, I mean, any of these robots show you the basics of coding all the way to coding with Python. So they're fun for all ages. I would say even a teacher would be more than happy to get their hands on these great tools for learning. So community colleges, high schools, elementary, nursery school, libraries, I think it's all inclusive on both of these products. They're both amazing, and many different programming languages are learned.
Yeah,
And
especially
lastly,
places where it's an introduction to computing and coding. So even if it's a 14-year-old, but have never been, or an adult that's never been exposed to computational thinking and coding, this is still a good on-ramp to start to learn those principles. I mean, certainly a pre-service teacher at a university like the University of Texas at Austin, that would be awesome if pre-service teachers were learning robotics and coding. Specifically for University of Texas, they also have a program called We Teach CS that helps to certify educators if you're trying to become more knowledgeable about computer science.
And lastly, Tracy is asking how this professional development is included in the price of the class pack or is an additional cost?
The great question. Yeah, so for us, all of the cost is in the class pack. So you buy the robots, the batteries, and the color tiles, and you get free access to over 100 lessons. You get access to us and Robot Lab to provide training and support. No student licenses, no reoccurring fees. It's all built into the classroom set.
Oh, thank you so much. And thank you everybody for your questions. We still have some time. If you guys have more questions, please feel free to ask right now. We have the experts here. And then Ross and Ronald, was any of the questions very exciting to you for a future winner, or what do we have?
Yes. There were some great questions, so really appreciate it. Just to mention one of the other things, and Amy, you can probably put our email in there, is we also, if you want to invite your other teachers, we can do a similar demonstration for them. Our PD is also included, but I love following up and talking to teachers and make sure, that you don't have any problems, and we can just jump on a video call. So that will be good. We will be at ISTE, so please come and see us. And right, for question time. Now, we had a look and there were some really, really good questions, and hopefully we've answered them all. But if you have got any more questions, either contact Amy and she can get in touch with us. So I think, let me just have a look.
I think we've picked a winner.
Yeah, I think Brooke Roberts, you are the winner. I love how to integrate KaiBot and the lesson plans and the platform, and all of that is really, really important these days to get that engagement. And the reason we also chose you is we believe in collaboration, but also our motto is that if we can engage kids, the fun comes automatically. So it's really about that building future trailblazers. So if you can just give your details to Maria, Brooke, you will get a KaiBot.
Thank you so much. This is awesome, guys. Thank you. I don't think we have more questions, but is there any comments from your side, guys, that you kind of want to share about your products, or is there any events coming from your side that we might know about besides ISD? Are you guys doing another webinar or other things that maybe we can, maybe our attendees would like to attend as well?
Yeah, we've got a free trial program starting soon as well for both of our products. So for Kai's Clan products as well as KaiBot. With our Kai's Clan products, it does IoT, it does, you can use Minecraft. There was a question about using Minecraft with it. And in that product, you can, create a character. So let's say you're doing something on Mars, create a character and then sit inside that character. And you might have designed that in Minecraft and use that with your physical robot. So blending the virtual and physical is kind of what our speciality is, and creating a high level of engagement.
And if you go to our website, kaiseducation.com, and you just go to events, you will see we'll be at the library conference in Texas coming up. We are doing quite a lot of mathematical conferences. Rudy Neufeld is actually doing those personally. So yeah, keep an eye on our events page and we keep updating of what's happening. And then you can always come and visit New Zealand and just come and play with them right here in our studio.
Yeah, and so I can add too, for advanced learners, we have some lessons with Raspberry Pi. So you can mount a Raspberry Pi into the top of Marty and then turn Marty into an autonomous robot. We also have some lessons with 3D printing. So if you have access to a 3D printer and you're like, gosh, what can I do with this? We provide step files and STL files so that the students can make parts and augment Marty and be more creative there. Likewise, we and Robot Lab will be at ISTE. I'm going to be at the Elementary Teaching Conference in Texas as well. So yeah, we're all around. We're all busy talking to educators. So stop by and take a look.
Yes. Guys, thank you so much. I think we're done. If you have more questions, just please feel free to send us an email. Thank you so much for your time. I know at the middle of the day is kind of a little busy, but thank you so much. We are going to send this recording to you guys. Congratulations to Brooke. I got your details, Brooke. Thank you. So I'm going to send it to Ronell. And then thank you, of course, Case Education and Robotical. Thank you for your amazing products and everything you do for education. And this is exactly why RoboLab partnered with you guys, because this is just amazing. So thank you so much, guys.
Thank you.
Thanks,
Very
Robot
welcome.
Lab.
for joining.
Thank you, guys.
Thank you.
Bye-bye.
Bye-bye.
See ya.